Next is cluster analysis. Clustering is the task of dividing the unlabeled data or data points into different clusters, such as similar data points fall in the same cluster than those which differ from the others. So the cluster analysis is a collection of approaches for categorizing instance or objects into grouping called clusters. Data is divided based on the similarity and then labeled to the group through the analysis. In simple words, the aiming of the clustering process is to segregate groups with similar traits and assign them into clusters. Clustering describes the method of aggregating data that shares similar attributes. Consider a large online retail like Amazon. Amazon can cluster sales based on the quantity purchased, or it can cluster sales based on the average account age of its customer. So what the Amazon could be doing here is by separating the data into similar group based on shared feature, analyst may be able to identify other characteristics that define future activity. There are types of clustering. Broadly speaking, clustering can be divided into two subgroups. You can see in the picture here, a hard clustering and soft clustering. What is hard clustering? In this, each input data point either belongs to a cluster completely or not. For example, in the above example of Amazon, each customer is put into one group out of the 10 groups. In soft clustering, in this, instead of putting each input data into a separate cluster, a probability or likelihood of the data point being in those clusters is assigned. For example, again, from the above scenario, each customer is assigned a probability to be either of the 10 clusters of the retail stores. What are the different types of clustering algorithms? So connectivity model. So itself, the name suggests these models are based on the notion that the data point closer in data space exhibit more similarity to each other than the data points lying farther away. These models can follow two approaches. In the first approach, they start by classifying all the data points into separate clusters and then aggregating them as the distance decreases. The next approach in connectivity model could be all the data points are classified as a single cluster and then partitioned as the distance increases. Also, the choice of the distance function is subjective. These models are very easy to interpret but lack scalability of handling big data sets. Example of these models are the hierarchical clustering algorithms and their variants. Next type of algorithm is centroid models. These are the iterative clustering algorithm in which the notion of similarity is derived by the closeness of the data points to centroid or cluster center of the clusters. The k-means clustering algorithm is a popular algorithm that falls into this category. In this model, the number of cluster parameters required at the end has to be mentioned beforehand, which makes it important to have prior knowledge of the data set. These models run iteratively to find the local optima. The next algorithm is distribution model. These clustering models are based on the notion of how probabilities that all the data points in the cluster belong to the same distribution. These models often suffer from overfitting. A popular example of these models is expectation maximization algorithm. Last is density model here. These models search the data space for areas of the varied density of data points in the data space. They isolate different dense regions and assign the data points within these regions to the same cluster. Popular example of this model are DB-scan and optics. These models are particularly used for identifying clusters of arbitrary shape and detecting outliers, as they can detect and separate points They are located in the sparse region of the data space, as well as points that belongs to the dense regions. You must be wondering, where do we actually apply this clustering? Where does the application of clustering belongs? So let me just give you a little bit of understanding. So clustering has a large number of applications spread across various domains. Some of the most popular applications of clustering are recommendation engines, market segmentation, social network analysis, search result grouping, medical imaging, image segmentation, and anomaly detection.